Yeah, good morning, students. So, the next topic is about eccentric connections. So, in these eccentric connections, there will be two types again, bolted connections and welded connections. So, these eccentric connections, when we'll have eccentric connections, means eccentricity. Eccentricity is nothing but there will be the line of action of load is not along the centroid. So if you observe the previous case, just like butt joints or lap joints, whatever we have connected earlier using bolts and welds, so there these kinds of external loads were there. So the line of action is about the centroid. Okay, at the center line only those forces are going to act. But in coming to these eccentric connections, there will be some distance. So for this same kind of problem, if this load is not acting along this center line, if it is acting at some corner point, and there will be some eccentricity. So this distance, the distance between centroid to the load, will be called as eccentricity. So here mostly we'll observe these kind of eccentric connections in uh, beam column joints. So beam column joints mostly will use I sections for these beam column joints, right? So for those I sections, so let us say this is cross section and this is a vertical column of I section. Okay, so in this case, if you are connecting, this is column and you are connecting some beam here. Okay, just imagine it, this, try to imagine this picture, and I am going to connect this with some plate. Okay, so I am going to use here the bolts. So in this way, but the external loads, in this case the external load is acting at some other end P. So the bolts were here and there is no force at this, in this area. The force whichever is acting is here. So due to this force there will be some eccentricity develops here. So this kind of eccentricity we are going to discuss in this topic. So these eccentric connections will also be called as bracket connections. Bracket connections or eccentric connections, both are synonyms. So again, first I'll go with the bolted connections. So in these bolted connections, again there are two types. One is of, I'll just call it as type 1 and type 2. The major difference between type 1 and type 2 is line of action of loads. So that line of action of loads, line of action of eccentric load is in same plane with bolt group. So that means same bolt group uh, line plane and also the load plane is same, then we can call it as type 1. So I'll show that in the diagram. So here I am representing with the line diagram. So this is a front view of eye section. So here in this picture I have shown you the three-dimensional view, right? So for this picture I am looking in this way. So if you are looking the same picture through this way, you can able to see this diagram. So at the center will be having the web. Okay, so that web will be shown here with the dotted lines, two dotted lines. So the load will be acting here. So now the bolt group is here on the two sides of the web. So in this way we have a connection. This type of connection is called type 1. So here the bolt group is in this plane, okay, this front plane, and also the load also external load is also on the same plane. So this will be called as type 1 connection. And also coming to the type 2, line of action of eccentric load is in perpendicular plane with bolt group. So now you have to observe this little clearly. So the same diagram, now the middle part which we are looking here is this is the flange now, and these two are webs. So if you observe the cross section, so this is your cross section. So in this first case, so you can see the cross section here. That means the flange, I mean whatever the flange area we are having, this is the main line, and these two are webs. And also in this case the diagram was like this, the eye section, so that you can imagine this is for the top views. These two are top views. So this area we have represented here, we are going to see through this line, and here through this like this we are looking this picture. This is a side view. So for this eye section, now the connections are there will be some extra plate added here. So the bolts are anyways in this plane, and to the bolts plane exactly perpendicular, in the perpendicular plane we will be having the load. So bolts are on in this plane, I mean in this plane bolts are there, but load is on the perpendicular plane. So for this first picture, if you are observing, for this plane bolts are same here, and in these two pictures bolts are same common, but here along with the bolt group will be having the load also on the same plane, but here perpendicular plane. So exactly if you are placing some plate here in the perpendicular line, so to this plane, to this plate will be having the, okay, I hope now you can see this little clearly. So to this plane will be having the load. So this is of type 2. Okay, so I hope this is clear. Bracket connections of there are of two types. One is eccentric load is in the same plane with bolt group, and second one is eccentric line of action of eccentric load is in the perpendicular plane with the bolt group. So now we'll see how to solve these two types of problems one by one. So first, going with the type 1. Here you can see the type 1 bolted connection diagram. Okay, so here we are having almost 6 number of bolts. So this bolt group, how we are going to analyze, we'll see now. So there is a eccentricity here. So exactly you need to take the center line for this web. So from this center line to this external load, there will be some distance that is called represented with E naught. This is eccentricity. Okay, so I am taking out these bolt groups out now. So all 6 bolts are like this. So now coming to the individual centroid. Okay, so for the almost we will be having 3 number of bolts in each row. So the centroid will be at this distance. That means at the center bolt, half of the at the center of the middle bolt will be having the centroid. So and also the centroidal line. So from here, from this center line, center point to each bolt, there will be some distance. Okay, so this distance to this bolt, okay, let us number them like 1 2 3 4 5 6. Like for these all 6 bolts, there will be some distance exist. So we can name it name this distance with r1, r2, r3, r4, r5 and r6. Okay, and also there will be some different theta angles for every bolt will be having some theta values. So now this bolt group will also having some forces. Will represent the forces here. Okay, for every bolt. So due to this external load, so the external load is vertically downward. So due to this I mean for eccentric loading, usually what will happen, as we have studied earlier, like we'll be having some moment plus load. Okay, so for example, in a beam or anything, any member or any structure, let us say this only, if you want to replace this, if you want to transfer this load to the center point, how will going to transfer, forget about this, just for this only. So we can add same equal and opposite force here, right, at this point. So P and P with some distance of E naught, this is P. Okay, so this P and this P will form a couple that is of P into E naught. So finally we can replace this load with load P and also moment P E naught. Okay, one moment and also load will be going to act at this center point. So now to represent that, so for this exactly opposite reaction resistance force will be going to act in each bolt. So that force I am going to represent with the F1. So this F1 is force due to direct shear, and in this case the moment will be called as torque. So F2, torque is nothing but a circular moment. Okay, So here we'll be having torque and load. This load is of shear, direct shear. So secondly, F2 force is due to torque. So the directions you have to observe clearly for each bolt. The F1 direction will be exactly opposing the load P. So a load P is vertically downward. So F1 is obviously for each and every bolt it will be upward direction. F1. And coming to the torque, force due to torque, F2 will be in the perpendicular direction. So now there is a line from center point, right? So to this there will be some perpendicular direction. So here in this direction F2 will be there. And coming to the bolt number 2, for this is the R. So to this the perpendicular direction is vertically downwards and F2 direction is this. And coming to this bolt number 3, R, to this R radial distance, the perpendicular direction is here, it is F2. And also for this bolt number 4, the perpendicular direction is this, it is F2. Sorry, this one is F1 and so this is F2. And for this perpendicular direction is same, so F1 and F2 directions are same. And for the last bolt, to this perpendicularly F2 acting here. Okay, I hope now you can, this is little messy, but I hope you can clearly understand what are the directions of F1 and F2. Okay, if this is clear, then we are going to move to the next part, like to calculate F1 and F2 values. Okay, so now we have dissolved all the forces like F1 and F2. So now the total force, if you want to calculate in this joint, that will be for every bolt, total force in each bolt. If you want to calculate, then simply calculate the result of F1 and F2. Okay, that will give you the total force for each bolt. So how much bolt strength you need to provide, that you will come to understand based on this F1 and F2 values only. So this resultant force, let us say this R should be less than bolt strength always, because R is nothing but due to, from external loads we are calculating this resultant force. So this much of external load is coming to each bolt, means the bolt need to resist all those force. So this the bolt strength should be greater than the resultant force. So from our assumption, the direct shear force is sharing, so let us say assumption is going to share equally for all the bolts. That means this F1 is nothing but P by N. N is nothing but number of bolts. So this force P is going to share equally to all the bolts in the bolt group. So now coming to the F2. So if you observe, this F2 is perpendicular to all radial distances, right? So the relation between F2 and R is F2 is directly proportional to R. So to remove this proportionality, we can add some proportionality constant F2 equals to KR. This K is the proportionality constant. So from here what we can write, K equals to F2 by R. Okay, so just keep this aside. So now by taking the torque about the center of rotation of bolt groove. So torque is nothing but similar to the moment, right? So for this center, if you are going to take the torque, so force into perpendicular distance, that is F2 into R, whatever for each bolt, R1 or 2, whatever, for every bolt it is F2 multiplied by R. So for F2 what we can write, it is equals to K into R. So this is going to be KR into R, that is KR square. So for all the moments, total resisting torque will be now, torque will be equals to summation of KR square. So in this K, what we can write, K is nothing but F2 by R. So here K is constant, we can take it out. So that is equals to F2 by R into summation R square. Okay, so this is our total resisting torque. So the resisting torque should be equal to the torque over the connection. So whatever the torque, that means internal force you can call it as. So this is the internal capacity. Okay, this will be equals to M equals to F2 by R into summation R square. So M is nothing but P E naught is equals to F2 by R into summation R square. So this is resisting force and this is external moment. So external torque, and this is resisting torque. So now equating these two, will get F2 value as F2 equals to P E naught R by summation R square. Okay, so this is our F2. So here by using this formula, if R is, can also write it like F2, if you are calculating for first bolt it will be R1 and for second bolt it will be R2, like this. If you are calculating for